And this will be on your test, yes. So the first one, because before now we had our old area formula. Do we remember our old area formula for a triangle? Yeah, like just base times height divided by 2. So sometimes it's written like this, 1/2 base times height. Now, we saw in this unit that we started to deal with triangles that weren't right-angled triangles. Before, we always had right-angled triangles, so one side was always the height, and you could easily figure out the area using the old formula, 1/2 base times height. But sometimes we get questions like this that don't have the height. That's not to say that, using our old way of drawing the height and figuring it out with a squared plus b squared equals c squared or SOHCAHTOA isn't a bad thing. But what we can do is we can make a new formula so we don't have to take that extra step. And the idea is basically like this. So if you had a triangle like this one, and instead of BC sine A. So this would be little a, this would be little b, this would be little c. If you had this triangle, and you were thinking about angle A, and you drew in the height h. Yes? Yeah, I screwed up. Thank you. There we go. Thank you. If we drew that triangle and we had angle A, we could figure out the height. Because what do we know about angle A and the height? Well, you know that there's a relationship that sine of angle A is equal to h over c, because this would be a right angle triangle. That's just using SOHCAHTOA. And if you wanted to get h by itself, you could multiply both sides by c. So h is equal to c sine A. And you might remember us doing that same thing when we made the sine law. So now if we think about our old formula was 1/2 base times height, and b is the base that I drew in our picture. But now instead of writing height, since the height is equal to c sine A, we can just substitute that in.
So what should we be writing down right now? Like all those triangles?
Yeah, you can, and then this will be our example. So this is the proof. This part of the, let's erase this one and do it down below. But if you want to write this down first, okay, this is where this formula comes from. Okay, now all you'll have to do is that this is on your formula sheet, and you'll be able to use it. The first big A is for area. It's not really good that we're using 2 A's in a formula. I actually really don't like that.
Put one in like block letters.
Yeah, this is fancy A.
Or use that.
There we go.
Use the calligraphy thing.
Yeah, that's problematic actually. That formula should probably be changed on the formula sheet, because they shouldn't use the same variable twice.
You should sue whoever
So
made the formula.
the first A is
Great.
the second one means the side A or angle A or whatever.
The first one means area,
Okay.
and the second one means angle A. Yes.
Just do it AR.
So now let's do that example, which would be find the area and we had this angle, I had it 30 degrees. Did I have the 5 up here and 6 down here? So we want to find the area. Again, 1/2. And it is always that the angle has to be between them because the formula says BC sine A. So the sides don't match up. The B and the C don't match up with the A. So there's no side and opposite angle in the formula. So again, do I have, if I'm using 30, I can't use this side. I'd have to use the 5 and the 6. So 1/2 times 5 times 6. Sine of 30. A little bit of mental math without a calculator. No, you can do it.
Humanly impossible.
No, this could be a non-calculator part of your exam.
50 times 6. 50 times 6. So 30 over 2, which is going
7.5. How do you know that? Sine of 30 is 1/2. Half of 6 makes 3. 3 times 5 makes 15. Half of 15 makes 7.5. All right. So that's our one new area formula. The second area formula I'm not going to provide a proof for.
Is it more difficult than first?
Yeah, the proof is longer.
So this is like another thing that we need.
This is on your formula sheet as well.
Okay, so this doesn't elastic.
That look crazy?
Holy moly!
And in addition to this, you have to know what S is, and S is equal to A plus B plus C divided by 2. That's the formula.
S, we're going to have to write that.
That is the whole entire formula.
You know what?
This is called Heron's formula for area. He's an old mathematician from Greece.
I thought trig was supposed to be easy.
This formula is actually really easy. So we use this formula in an example where you have a triangle where you have all 3 sides. Again, you could take the time to try and figure out the height, but the problem is if wherever you draw the height, you won't have enough information to figure it out using SOHCAHTOA. You could use the cosine law first to find an angle and use the other formula. However, this formula works really nice and simple when you know all 3 sides. Now S, the S here stands for semi-perimeter. And the reason it's a semi-perimeter because it's half of it. If we add up all the sides, 6 plus 7 is 13 plus 9 is 22, and divided by 2, we would find in this one that the semi-perimeter is 11. So the area of this triangle is the square root of 11. 11 minus A, again, it doesn't matter which is A, B, and C. You just have to subtract 11 minus 6 and 11 minus 7. And it doesn't matter the order as long as you're subtracting every side once. So we get the square root of 11 times 2 times 5 times 4. Mental math. 440. Can you simplify that radical? Yes, you can, because you can pull out a 4, right? Because it's square root of 4 times square root of 110, just to practice that. 110 is 2 times 5 times 11, so you can't simplify that one. And that's the area.
Question?
Yes.
Can't you just cut it in half and find that?
Find the height?
Yeah.
How are you going to find the height? Because as soon as I cut it in half, this,
9 and
no, it doesn't necessarily go right in the middle. In fact, it won't go right in the middle and make it 4.5 and 4.5. A really good example is you could find the area of this triangle, where I make this 2, this 8, and this, say, 11. Can you see that if you draw the height, it definitely doesn't cut it in half? Sometimes, this one's close, right? Makes you think maybe you can do it. Whenever you're wondering if maybe you can do something, try to draw an extreme example and see if it still works. So there will be a question for area with both of these formulas, but they're just plugging into the formula. They're relatively easy.